Right, welcome back. So this time around we have a question on thermal properties of matter. Fig 4.1 shows a stainless steel saucepan being heated on an electric cooker. The saucepan contains some water. State what happens to the water particles as the water temperature increases. State what happens to the water. So when you apply heat to a substance, the particles inside, they will gain kinetic energy, right? So they'll begin to vibrate or move faster, right? So gain kinetic energy. That's what happens when heat is added to a substance. The molecules or the particles inside that matter object, they increase movement, the speed and everything. Right, the saucepan contains 250 cubic centimeters of water, and we're told the specific heat capacity of water is 4,200 joules per kg degrees Celsius there. The density of water is 1000 kg per cubic meter. Show that the mass of the water in the saucepan is that. So first of all, we don't just rush to make some calculations here. So we look at what we're given, right? We're given the volume and the density and the specific heat capacity. I think from the volume and the density we can calculate the mass of this object. But what is key is to take note of the unit of the density and also the unit for the volume. So now we need to be very clever. We have to convert the 250 cubic centimeters into cubic meters. That's what we need to do there. Converting 250 cubic centimeters into cubic meters. So 1 cubic centimeter or 1 cubic meter is equivalent to how many cubic centimeters? So that is very key to understand. So let's assume we have a small box here, right? Sorry about that. Let's assume I have a small box there, a cube, right? I don't usually encourage people to memorize those prefixes and stuff, right? So if this is 1 meter, this is 1 meter, and that is 1 meter, it means the volume of this cube is 1 cubic meter. 1 cubic meter. But then we know very well that 1 meter is actually 100 centimeters. This is 100 centimeters. Also here we have 100 centimeters. So if we are to calculate the volume in cubic centimeters, it means we are saying 100 times 100 times 100. I'm just trying to look for a relationship between the two. So this will give us actually 1 million cubic centimeters. So that's the relationship now that exists between this guy and this guy. Hope that makes sense. So now we are given 250 cubic centimeters. We need to convert it to cubic meters. So what we are going to do is to divide, right? We are dividing 250 cubic centimeters by 1 million. So that means the volume now is equal to 250 divided by 1 million. Right, this will give us 250 divided by 1 million there. Right, 2.5 times 10 to the power minus 4 cubic meters. Then from the formula, right, density is equal to mass over volume. It means that mass is equal to density times volume. So what does this imply? It means that the mass is equal to, the density is 1000 times 2.5 times 10 to the power minus 4 times 1000 there, right? This will give us 0.25 kgs, right, shown. So what was key there is to understand how you convert the cubic centimeters to cubic meters. Right, let's move on to the next question. Now the question asks us to calculate the energy required to increase the water temperature from 20 degrees Celsius to 65 degrees Celsius. So remember, we're given the specific heat capacity of water up there. Right, so energy is equal to mass times specific heat capacity times change in temperature. So since our specific heat capacity is a unit of degrees Celsius, there is no need for us to convert these two guys to the thermodynamic temperature, which is the Kelvin. So we're going to use the same thing. The mass, we just calculated it there. So the mass is 0.25 times the specific heat capacity, that's 4,200. The change in temperature, 65 minus 20. This is equal to 0.25 times 4,200 times 65 minus 20. I'm getting 47,250 joules. So in most cases, we have to check from the raw data values that we used. If you look around, most of our values there are to two significant figures. So that means we can round off our answer to two significant figures, which is 47,000 joules. In other words, this is equivalent to 47 kilojoules. Remember, kilo means 1,000. Right, so you can always leave your answer in kilojoules. Right, so this is how we're supposed to deal with this one. I hope we learned something from this as well. See you next time, and thank you for supporting my YouTube channel. Please don't forget to like and subscribe.